Hey everybody. Yeah, it's Wednesday. It's party night.
6 people.
I know, right? Yeah, it's great. No, thanks for showing up, everybody. Actually, this will be even though it's not required for you to be here tonight. I think it's a good night to be in person. You'll get to see and like really experience pair programming better if you can observe other people doing it. Spoiler alert, I will be asking for volunteers to come up here and pair with me. And so then yeah, you'll get to see some of your peers doing it. And this is all prepare for next Wednesday when we'll all be doing pair programming, but I'm getting ahead of myself. Welcome to class, everybody. It's good to see you all. Happy Wednesday. I know it's chilly outside, so thanks for coming in. Let's see here. We got some exciting stuff tonight. I want to start off with some test-driven development, kind of stuff we didn't get to last time. And then I also want to do what we call an operating theater exercise for pair programming. Before I get to Prime Minister's questions, there is one thing I wanted to point out about tonight's class. So uh, on Monday, I loved the class. We had a great session together. We had lots of great discussions. I feel like there was some good learning going on, but oh my gosh, we ran out of time. And I felt like we just barely wrote like one unit test, and then it was time to go. I was looking at the stuff I wanted to cover this week, and I realized that I've got a bunch of like introductory stuff. We're still at the beginning of the class. There's stuff about like I just sort of like handouts and things like that where about how to test your project, how to document your project one. And I'm like, there's no reason for like all of us to be here together just to hear me telling you things as opposed to us interacting and us coding together. So I on Tuesday night I pre-recorded basically me talking to all of this content. So there's already a screencast for this week where I cover, sorry, for tonight's class, where I cover project one, how to test it, how to document it, how to submit it. And so then happy to answer any questions about it if people have already watched it and have some questions they want me to cover. Otherwise, happy to take questions on Slack also. I got to apologize. The beginning of the term is a little compressed. We do have a holiday on Monday. And so then, there's that break here in the beginning of the term. But sort of once we get into the end of January and February, I think things will be a little better spaced out. So with that, what can I tell you? I know it's only been, a couple days since we last met, but what's come up for people? Any observations or queries or feedback that you'd like to share about what's going on in the course? Yeah. Yeah. Okay. About six. Thank you. 1.4. Oh, sorry, subpackages. You're 144. Oh, here we go. Okay. Static inner class. Okay, so static inner class, and that the important number. Okay, so some object dot important number. What happens if you try to access X or the answer from the outer class? What does this mean for the static inner class? Trying to create a sub package of this package is named static inner class. Does it work? Why not? Oh, that's interesting. So let's see here. Static inner class is just an inner class of this one. It's got a value of 3. So I would expect this to return 3, right? Is that what you did? Yeah. Okay, cool. Yep. And then like this comment, like what does it mean? Yeah. 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 So like what is this X and the answer? So what is the answer here? Oh, no, here it is. Okay, the answer is an instance method of the outer class. It always returns 42. Okay, and so then I think here it is. Gotcha. So here we have an anonymous subclass that overrides it to be 23. And then, yeah, questions from all y'all. Yes. Maybe I can. Up, down. It's always so confusing. Okay. I get these Zoom windows also. Let's see here. Okay, yeah. So here we override it with an anonymous inner class. I haven't returned 23. And Yeah, so what happens if you try to access X or the answer from the outer class? That's interesting. What does it mean for the static inner class? Try to create a subpackage of this package, which is named static inner class. That's interesting. Subpackage of this package. The package is named static inner class? Huh. I'm guessing what they're hinting at here is the various namespaces and stuff. So a static inner class. Okay, so I don't remember. No, the lectures probably haven't covered inner classes yet. And so then it's not surprising that this is kind of unfamiliar to you. So when you have a class declared inside another class, so well, let's see here. I guess we just have to look at the. Okay, so here is an inner class called other inner, which extends about inner classes, about inner class. So if you have code inside this inner class that wants to reference a field of the outer class, like how do you do that? And it kind of makes sense to do that, right? Okay, so your outer class has some state, and inner class needs to access that state. It's a reasonable thing to do. Unless the inner class is marked as static, there is an implicit reference to the outer instance of that, meaning that you've got an instance of that class and you create an instance of the inner class. You have two objects and they're implicitly connected together. And that implicit connection allows the inner class, the inner instance to reference an instance field of its outer class. Okay. And this is cool because this is cool, but it also means that whenever you have, in order to have an instance of the inner class, there must also be an instance of the outer class associated with it because it has to have some object to refer back to for those fields. And you don't always want this. Sometimes you have an inner class that is really, in many respects, kind of decoupled from its outer class. You can just have the inner class there because it's sort of it is logically speaking, or it makes sense to group them together in that way. So have them, they're related to each other, but you don't necessarily need to have an outer instance. And if you don't want that, you mark the inner class as static. So like the static inner class here doesn't have a reference out to its outer class. So for instance, I think what it's getting at is the following. So here, if I have an important number and I try to have it call the answer. Oops. Yep. Right. It's interesting that it's a warning. There, I was going to be an error. It's Yep. It's basically saying that you can't call. Maybe that is an error. Wait a second. Is that the error? Yeah. Okay. Good. That is an error. Okay. I was expecting a stronger underline there. Maybe it's because of the Oh, there we go. Right. Because I had it. It was highlighted because it was in the search. If I try to call the answer from a method of the static inner class, it doesn't compile because it's like there is no outer instance of this, as opposed to up here, if I have, public void foo, oops, if I have a method here, now I can call the answer from here because this is not a static inner class, it's a non-static inner class, and there is an implicit reference out to the instance of the outer class. Kind of esoteric stuff. I think the most valuable thing is that you might encounter this sometimes when you're using inner classes, especially anonymous inner classes, like we saw that example of the anonymous inner class, like right up here. So then, this is just interesting syntax right there. Yeah, there you go. Yeah. So practically speaking, it's cool that they're like all these like, go think about this and go try this. Don't spend more about 10 minutes trying to figure out. It's like, hey, if it's something that's kind of beyond you right now, that's okay, right? I mean, I'm guessing by the time you get to this point, you're already learning a lot about the language, which is accomplished. And so be pragmatic about how much you invest there. But I'm really glad you asked about it, though. Thanks. And did my explanation answer your question? Yeah. Yeah. And it might also be, I don't know. I mean, like, yeah, that's strange. I would not have tried this one. So let's see here. If we have this, so like what it would be a sub package, new package called intermediate.static inner class. And does that cause a problem? I mean, I don't see any problem. So I don't try to create a sub package of this package with the name static inner class. Does it work? Why not? I don't see why it wouldn't work because I mean the name of a package is completely different. Maybe if I tried to import something from there, maybe like if I tried to import. No, okay, I don't quite understand what that means. Yep. So sorry. No. Oh, stump the professor. Yay. Okay. Well, the assert equals is still valid. Like this comment though, don't need to do anything. Meh. Yeah, the comment. Okay, come on. Yeah. Again, be pragmatic about it. Yeah. 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 Please do. Yeah. Okay. Yeah. Sure. I like this one. So then, yes. So then, probably, unless you change this, this fail method will end up being called because you get a class cast exception when you try to cast the variable O to a sleepable. Now, why do you think that is? Why does this code always get a class cast exception? Yeah. Yes. The runtime type of O is an object. Object does not implement sleepable. Therefore, at runtime, when we attempt to cast the runtime object, equal to object, to sleepable, oh, it can't do it, so get a class cast exception. So how might we change this code so that a class cast exception isn't thrown? Yeah, I think the intent is that you then you assign O to a class like I think it's grandparent. Yeah. No. Well, hey, also yeah, you can delete the cast. It's like yeah, right there you go. It works, but is it the spirit? Yeah, it's like come with the whole thing out, right? Yeah. No, yeah, yeah. So no, yeah. So I'm guessing that yeah, just have it use a grandparent here because grandparent implements sleepable. Yeah. Yeah, this is more about types and stuff like that. Yeah, nice. Yeah. Yeah, the complicated cast. Let's see here. How can we access the parent's ability to complain if the reference is held as a superclass? Grandparent, parent equals new parent. Parent is also a grandparent. Oh, I guess it is. Okay, a parent is also a grandparent. How can we? Well, I think if you just say parent. Oh, okay. Yeah. Oh, thank you, AI. Yeah. Okay. So yeah, here. Oh, that's interesting though, because it's like, no. Yeah, it's that's not gonna do what I think it is. Yeah, right. How do you do that? Do you say I don't I don't really think you can. Wait, parents' ability to complain. Sorry, let me look at parents. Oh yeah, no, parent overrides this, overrides complain to say the TPS reports thing. So yeah, you should just be able to say you don't even need to cast it. You can just say parent.complain. Oh, because it doesn't okay, because it's not declared. Okay, sure. Then yes, you have to cast it. Yep, exactly what the AI told us to do. Yep. Yeah. Nice. I'm glad you guys. I'm sorry. Glad you all are digging into the koans. And yeah, you're actually you're ahead of classes in the past, so this bodes well for your understanding of Java and your ability to get done with the assignment too. Yeah. it won't throw an, yeah, good question. So it won't throw an error, but it won't be a class cast exception because at runtime, the runtime type of the parent is of the parent variable is parent, right? Unlike this one where the runtime type is object. So here, unless you change it, you will get a class cast exception when you tried to take at runtime a runtime object and class it to a sleepable. Here you will not get a runtime exception because the runtime type of parent is already parent. Yeah. Nice. Okay. Yeah, good. Okay. Anything else I can tell you? Did anybody have a chance to watch that screencast I put together last night? No, it's okay. No? Okay. Please do so. I talk about the first project, which is assigned tonight and due in 2 weeks. I probably didn't call out the when's project one due. Yeah, January 28th. So that's 2 weeks. Yeah. So please get please get your koans in a nice place where either they're finished off or where you can start dedicating some brain cells to project one. It's things overlap in this class. It's all part of the challenge of holding two things in your mind. So. Okay. Anything else for Prime Minister's questions tonight? Okay. So on Monday, we were talking about the student project, and you all brainstormed some awesome test cases for student, both for the student constructor and for the student main program. And we watched a little cheesy video from Uncle Bob Martin about test-driven development, and then we saw like 2 unit tests. What I'd like to do now is spend for about a half an hour or so doing some test-driven development to show you more about unit testing and to demonstrate the process by which you do TDD. So I'm going to be typing and probably asking some questions, and so then I'd appreciate your guidance in terms of what we write, especially on the implementation side. So I'll write the test, and I'd like you all to help me write the implementation. So let's go back to the code that we were working with and sort of get our IDE in a good place. So let's see here. I think we had no, where's the student? Where's student? Oh, the student's off the buffer. Fine. Okay, so here's the student class, and we also want the student unit test, so student test. And I like to split screen things. I'm going to make it a little bigger. There we go. And student test, I'm going to do then split and move right. Okay. I guess they're not exactly the same size. We'll see what fits in the page. So let's see here. There was this out of the box unit test that we had, which was a student named Pat as Pat. So then we this demonstrates that the name of the student is what we passed in. Cool. And then we implemented a test that said all students say this class is too much work. Initially, this threw an exception, and then we modified the code to have it return what we expect. And now, yeah. Oh, yeah. And also we added what is kind of like the ultimate test case in this Dave student, where we create that example student, and ultimately we validate that the toString value of Dave is the big long string that we expect. Of course, we are far off from this right now, but I like having this here just so we can use it to validate, right? Just so we can go back every once in a while and check it out. But in the meantime, this test will remain disabled. So that's what we got on Monday night. Any thoughts on in the last couple of days about like what's happened? Anything that you wanted to discuss before we get started? Yeah. Sorry, okay, I missed the context. Sorry, which video? Which video? Uncle Bob. Yeah, okay. Yep. Yeah, it's actually perfectly fine to have a test have a for loop, right? It's really whatever the test needs to do. In that case, yep, he wanted to roll 10 rounds that are all zero. Yeah, that's how he implemented it. Actually, I think It's probably the best way to do it, right? Have a for loop from I equals, 1 to 10. Yep, good question. Well, if you need to have conditionals in the test, it's probably that's a good point. It's you raise up like a good, and we'll see this here, but you raise up a good point about unit testing, where you want your unit test to be appropriately simple. And if you find that your test does have branching logic in it, that's probably a smell. You're probably doing too much in it. You really want your unit tests to be targeted, so we're sort of like one path through it, one set of scenarios, one scenario, one condition through it. But as we develop more here, let's keep an eye on that to see if we inadvertently make some messy tests. Okay. So let's see here. Inspired by these tests, um, I want to do the following. So, actually, sorry, let me run things again. I'm gonna run them all first of all. So I'll do this here by clicking. I'll move over to keyboard shortcuts here pretty quickly. So I'm just gonna run everything, make sure everything is running as it is. Good, everything passes. And I'm going to momentarily disable the Dave student test and run this once just to sort of remind us where we are in terms of our ultimate goal. So, okay, toString doesn't contain anything yet. Actually, toString, I click on the stack trace here. Has an unsupported operation exception. Okay, this is good. Now I remember where we all left off. So I think the next thing that I want to do is I want to start building out my toString. And so the next thing that I want to say is that my toString contains the name of the student. So I'm going to write a test. And of course, just like all good tests, we expect this to fail. So toString contains student name. So I'm going to create my student and create student name. Oops, what do they call it? Get student name? No, get student name. I don't like that word get. We should change it, but we'll change that during the refactoring phase. Get student name. Well, I'm going to give it a name. And the name will be, I don't know, student. And then I'm going to assert that student.toString contains string name. Contain string needs to be imported. So I'm going to import it. It's one of those ham crest methods. Great. So I expect the student here again, Dave shows up in toString here. I want the student to be here. I'm going to run this one test. We should expect it to fail. Let's just make sure. Okay, not implemented yet. Great. So, okay, I don't have one of those silly hats. So then now it's red. Let's make it green. So how should we make it? How should we make it green? Yep. So what should we do in the student file? In from the toString method. Okay, great. Yeah, I like that a lot. So let's just have this say return this dot get name. Let's run the test again. And hey, it passed. Cool. Great. We have a passing test. Let's move on. Actually, let's refactor it. So like I didn't like the get student name. I want to change the name of this. I want to say rename and I want to call it create student named. There you go. Oops, that makes a little bit more sense to me now. And after I did my refactor, I want to rerun all of my tests here, just to make sure that everything still runs as expected. Cool. I'm going to commit this real quick. Any observations about what you just saw? Anything stand out at you about how we did a TDD round for this? So something that I wanted to point out, um, is that all I did to implement it was the very minimum. I'm sure a lot of you are like, oh, but wait, I know how to put two string. It needs to have this. I know. So do I. You know, but part of test-driven development is like having the discipline to to take these baby steps and validating every little baby step along the way. Trust me, it helps you go faster in the long run. And it tells you, when you rerun all your tests, it'll tell you if you've broken something. But it can be frustrating because there's so many more things you want to do, but you got to wait for it. So cool. Let's implement some more stuff. Oh yeah, question. Yeah. Yeah. Let's talk about that. So the Hamcrest APIs. Hamcrest is like this anagram for matchers, and I talk about it in the JUnit lecture. So methods like assert that and contain string and equal to, these are methods that come from that library, and they provide what I like to think is more human readable assertion statements than what comes out of the box in JUnit. And you look at the question. Yeah. Yes. Okay. It probably needs to be imported. If you have the assert that, then you can import contain string. I went by really quickly. Sorry, I will do that again. So I had IntelliJ import the method here, but if I delete this, it's not imported anymore. And now it shows up in red. Does this look like what you see? Yeah, right, yep. And so then, when I clicked on it, it said I want to import it. Probably what I did is I said option or control on Windows, enter, and then it pops up some options for importing it, and we just want matchers.contain string. Actually, it needs to be fine, and that gets it to work. Yeah, the import statement up here. Yeah, this is what IntelliJ adds for you. So yeah, so imports are how you reference other classes. So every class is uniquely identified by its package name and its class name. And so then inside your Java code, when you make a reference to something like a method or a class, you need to import it. So like when we have array list for where we use array lists, like array list right here, array list is in the Java util package. And in order to tell the compiler, basically, it's like, oh, when I mean array list, it is the array list in the Java util. You have to use the import statement up here. It's kind of like a pound include, but it's not. It's just it basically you're using it to resolve the names of classes, and then you can use this import static to import static methods within classes. Thanks for asking that. Great question. Okay. Let's do one more. Let's see here. Oh, let's do GPA next. So let's say okay. I'm just gonna copy this. Actually, no, I'm not gonna copy all the stuff from scratch. Test. Oh, say okay. So void, and this is just a Java method. Wow, AI. ToString contains GPA. Okay. No, I kind of like this. All right. Um, okay, pretty good, but not exactly what I want. Because if we go back and look, it's like, oops, Dave has a GPA of, so I really want this whole string has GPA of. So I'll say contain string has a has a GPA of, and then oh good, yeah, I don't need that call to double dot to string. Nice. Okay. And this is gonna gotta be watched for some peaks, but we're gonna see some new things. I'm gonna start using keyboard shortcuts so they're faster. So on the Mac, the keyboard shortcut for running an individual test is Control Shift R. So Control Shift R, and again, you get these pop-ups saying here's the command that I ran. So I'm going to run this unit test that I just wrote. Oh, good, it fails because it expected a string that contains has a GPA of 3.5, but instead it was just a string any name. That's all the ToString contains right now. Okay. How can we make this pass? What are your thoughts on that? Okay, yeah. So toString needs to have the GPA. Okay. How do we get the GPA to that toString method? So clearly it's like, okay, great, the name of the thing, and then have the name of the student, GPA of, oh, stop all that. Like how does that helpful? Maybe, I don't know. Do you think it's helpful? Maybe it is. That's true, but not quite useful yet. Has a GPA of, okay, again, I told you stop for a reason, of something, right? So we need to get the GPA. We'll just go this far. Okay, it is highlighting the GPA in red because it cannot find the symbol GPA. So what do we want GPA to be exactly? A double? Okay, yeah. And in particular, we want it to be, I mean, do we want it to be a local variable? Well, no, not really, because we don't get the value. The value is passed in the constructor. So, right, yeah. So like the GPA over here in the test code, right, is passed in the constructor of the student. And so now we need to get that GPA to the toString method. How do we do that? One at a time and enunciate. Yeah. Yes. Yeah. Make it a field, an instance variable. And IntelliJ makes that easy. So if you alt enter here, it'll give you various options on what you can do with this GPA thing. And we're going to say create a field GPA and student. Great. It created one. And then great. That's okay. We created it and like our code compiles, right? So let's run the test and see what happens. Oh, it failed. And it said, like expected a string containing has a GPA of 3.5, but was any name has a GPA of null. Yeah, what do we think happened there? Oh, first of all, string is a GPA is a string. I missed that. That should be a double. But I mean, do we think it's going to pass now? Nope. It says it has a GPA of 0. What's going on? Sorry? Oh, yeah, right. We didn't set the GPA. Where should we set the GPA? In the constructor. Nice. So here we go down to the constructor, and we say this dot GPA GPA equals the GPA parameter. So this dot GPA by prefixing it with, well, by using the this variable or this keyword, maybe is a better word for it. This dot GPA will refer to the field GPA. Just by saying GPA, this will refer to the parameter GPA. This is a common pattern that you'll see me use a lot, and I think it's a pretty common pattern in Java programs. So now that we've made that change, let's see if our test passes. Hey, it does. Super great. Okay. So now I'm going to commit this code. While I'm doing that, any observations you want to share? Anything that's on your mind? Okay. So, as you can see, what I'm doing here is I'm building up tests that basically validate more and more information about the toString. And so you can probably see where we're going next. We can have information about the classes that the students enrolled in, the gender of the student. Are you start getting the pattern of what we'll do? And so then there's being processing and things like that. And this is what unit tests are great at, right? Unit tests focus on things like the constructor for the for the student, and then we call the methods like says and toString and validate that everything's okay. There's another aspect of testing that I want to show off here, which is important for your assignments, and so I want to make sure to give it enough time here in class. That's called integration testing, which is a different, which is another flavor of automated testing that that focuses on the main method for the class as opposed to just the methods of the instance methods of the student class itself. So I talked a little bit about this in the screencast on Tuesday, but there are in this course you'll see two types of automated tests. One are the unit tests, and the other integration tests. Unit tests focus on the coding unit of just like the student class itself. They're fairly straightforward. You're basically testing the methods that you write just in one class. Integration tests deal with multiple classes doing more complex things. And primarily what you'll see, at least in the beginning of the course for integration tests, it's like doing more complex things. The command line counts as, or the main method counts as a more complex thing because what you're doing is you're taking in input from the command line and you're writing to standard output and standard error. And the logic of your main method is really important. If you look at your project one assignment, most of the logic's in there, right? And that's what you want to be able to test. But because the inputs and the outputs to the main method are different from just like any old plain Java method where it's like, oh yeah, I pass in an argument and it sets some state, or I call some method and it returns some value. Your main method works with standard output and standard error. And so then in order to capture standard output and standard error, the things that your program writes to it, we have to test it in a slightly different way. So I'm going to leave the student test, the unit test here just for a moment and move over to something called the integration test. And actually, I'll show you where that lives. So when we created our student, where is our student? When we created our student project, we saw that there was this student source main set of classes, main Java. That's where student lives. That's sort of the application code. That's the code under test. And for our unit tests, there is a test directory, a test Java directory that has the package, and there is the student test class. There's also this IT for integration tests. And this has a class called student IT. Now, student IT extends from invoke main test case. And invoke main test case is some code that I wrote that allows you to invoke a main method and capture what's written to standard output and standard error so you can test it. So here's an example of using that. I'll make it a little bit bigger so we can see it. And by the way, this uses JUnit. So you're still using the @test annotation and everything like that. You're still using Hamcrest, but there's this extra, there's this invoke main method that you inherit from invoke main test case, where you give it the JavaLang class for the class of the main method that you want to invoke. So it's going to be student.main. And it goes off and invokes it, and it calls the main method. It passes in arguments, and we'll see an example of how to do that shortly. And returns this object called the main method result. And this main method result gives you access to the text that's written to standard error and standard output. So if we run this test, it'll go off and it'll invoke the main method of student with 0 arguments, and it will store the result of what was written to standard error in this main method result object. When you call get text written to standard error, that returns what was written to standard error, and you can verify that it contains the string missing required student information, which is exactly what is printed out to standard error right here. So this is using some additional APIs, some testing APIs to be able to test the main method of your student. And this is going to be really important for your assignments too, because you're going to be writing main methods for your phone bill project. So I would like to I would like to spend a little bit of time writing some unit tests, write some integration tests for the main method. So let's see here. I think the first one I'm going to write, and so just as a reminder for the main method, here we go. Right. So when we let's first write the golden path test, the one that does everything. So that will be the following. So this will be like the Dave student again. Dave student is written to standard output. Or standard out, I guess probably is better. And by the way, you've probably noticed my test method names tend to be very long and descriptive. I think it's a good thing. That's what I like. I want it to be like just kind of in your face. Oh, I know exactly what this is. That way you don't have to guess, and also you don't have to write a big comment that explains it. So if you use a fairly descriptive name, it'll be clear, but it ends up being kind of long. Okay, so here I'm going to I'm just going to copy this because it's easier. Okay, so I'm going to invoke main. Now invoke main actually has two arguments. The first one is the class whose main method you invoke, and then a variable length argument of strings. I don't know if you're familiar with varargs from C or C++, but methods like where functions like printf, right, take a variable number of arguments. You can have 0 or more arguments to it. Java has the same thing. So what I can do is when I do the invoke main, I can have a okay, that's kind of neat. It's kind of guessing it correctly, but kind of not. This is the input that I want. So I'm just going to copy and paste this so it's a little bit easier. I'm just going to put it in here. And then I'm going to patch it up. Okay, so I have multiple arguments here. So these are basically the command line arguments that I would be sending to it. So the same way if I ran it on the command line, I put all these arguments here. They all need to be separate arguments, to basically like we can think of as a string array that is sent to the method, the invoke main method. And it's getting kind of messy, so I'm going to put this over multiple lines so it reads a little bit nicer. There we go. Oh, that's way better. And notice I have to have, well, actually, I don't need that here in Java because the escaping is the command line. Great in Java. Okay, so that is this. So basically, what I've done right here is, oh, look at that. What I'm basically doing here is I am invoking my main method and sending it all these arguments here. So it's the same way in my test case. Hey, when I send all those arguments, then I expect that what's written to standard output is the following. David's GPA 3.4 is taking 3.64, is taking 3 classes, blah, 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 blah. In Java, he says this class is too much work. I don't know why I cut it off. Okay, AI, the craziest things. What? Yeah, right, yeah. Decided hallucination, yeah, okay, cool. Well, this is ultimately what I want. So, and I think I'm also going to assert, actually, before I assert that, I'm going to say assert that result dot get text written to standard error is empty. So I'm going to say equal to empty string. And I'm going to import that. Okay. So now I'm going to run this test to see what happens. Actually, does it compile? It does. Okay. Yeah. I'm going to run this test. Okay. Not surprisingly, it failed. It's because, okay, it expected missing student information. Well, sorry, it failed on this first assertion because instead of an empty string, it got missing student information. Yep, that's exactly right. Now we know this test isn't going to pass for a while, so I'm going to disable it for now. Okay. I think the next thing that I'm going to do is the following. I'm going to write another test, which is student name is written to standard out. Yeah, okay. This is pretty okay. Okay, you can take 0 classes. Okay, yeah, this is good. Have a 0 GPA. It might not work eventually, but it's fine for now. Again, we don't want anything written to standard error. And then what is written to standard out contains string. So this is actually a pretty good test. When AI writes a test, I always double check it. I have to read it over to make sure that it's reasonable. And I believe it is. So what it's doing is it's invoking the main method. The first argument is the name. The other stuff really doesn't matter. And yep, the text that's written to standard error will be empty, and what's written to standard output will contain the name. Cool. Okay, let's run this. Oops. That's not the one I wanted, actually. Sorry, I ran the wrong one. I want to run this one right here. It failed because, again, something was written to standard error. So, okay, we don't want that written to standard error. So now we're going to start to implement our main method. So main methods read the command line arguments, do something with the command line arguments, and print stuff to standard output and standard out. That's essentially what our main methods in this class do, at least at the beginning. So what I want to be able to do ultimately is read the command line arguments and create a student object and print the toString of the student object to standard output. So I'm going to try that. Although I'm only going to write enough code so that the test passes. So given all of that, so I'm going to get rid of this right here because none of the actually do any of the. Oh, I guess it does. I guess we want this first test to still pass. So I'm going to keep this, but I'm going to say the following. I'm going to say only if arguments dot length equals 0 do I print that. Now I know AI was telling me to do something else, but I want to be very careful not to write any code that doesn't have a test associated with it. So what I want to be able to do sometime later is then, as I am sort of checking to make sure there are enough command line arguments provided, that's when I'll change that's when I'll change the logic to handle missing command line arguments. Right now, I kind of want to do happy path just to get my test passing. So I'll say in this case, all I really care about is the name. So the name will be arg0. And then I want to create a student equals new student. And see here, I have the name and then new empty array list, other, all that is fine. And then I'm going to print out, oh yeah, it doesn't need student.toString because if you just say print the student, it'll automatically invoke its toString. Okay, I think that's good enough. Let me run the one test. And it passed. So here's what we just did. We used the invoke main method to invoke the class. And actually, you know what? I don't even need these things. So I don't like having them there. I don't even want them. I'm just going to say, yep. When we pass the student name, it's written to. Yep. Sorry. When we invoke it just with a name for right now. I know it's not valid in the long run. We'll have to go back and add it later, but we don't want to add more parameters now because it doesn't make any difference. And then when we invoke the main method like that, it'll contain string name. So I'm just going to run it again to make sure it still passes. Great. I'm going to run all of my tests to make sure they still pass. Oops, something failed. Ooh, I like this. Oh, this is a great example. Okay, so I reran all of my tests, and this one failed because, okay, invoking main with no arguments prints missing arguments is standard error. Oh, look at that. So this failed, and it failed in a very interesting way. Oh yeah. Okay, it said it threw an uncaught exception in main method should not throw exceptions, which is true. In this class, I don't want your main methods to throw exceptions because when I run on the command line, I don't want to see a big stack trace. The user doesn't want to see your stack traces. Sorry, the user doesn't care about your code. In this case, I'm the user. So one of the features of the invoke main framework is that if your code does throw an uncaught exception, it automatically fails with one of these uncaught exception mains. And why does it fail? Well, the cause of that uncaught exception in main exception is that there was an array index out of bounds here at line 58. Now, what's wrong with this code? Right. It's like, oh, look, there are no arguments, print the error, and then keep on going. Oops. Now, great. I said, oh, yeah, we should exit from the program. And it's like, well, the main method should return. So I'm glad you used the word exit. One of the things that I talk about in that screencast I recorded on Tuesday is that for this course, please do not call system.exit from your Java code. So system.exit exits the VMs like exiting C, right? And it exits with a return code. And that exits the JVM. If in your unit tests you exit the VM, it's in the middle of your integration test, the framework that runs the integration test is going to get really confused because it's like, oh, the JVM, I had 10 tests in the suite to run. I ran 5 of them, then the JVM exited. What's going on? So please don't call system.exit. Instead, what we should do here is merely return. And so basically, oh, we found an error and we should return. And I'm going to run all the tests again and exit the pass. But this is why you always run all of your tests, right? I introduced a bug. I didn't realize it, but my test caught it for me. And who knows how much further I would have developed code with that bug in the main method. And cool, there it is. I'm gonna commit this, but anything that you want to discuss before we move on? Okay. Next, I want to write a test that validates that the GPA is included in the toString. Well, look at that. So smart. I think that's right. That looks pretty good. Let's take a look. Okay, so here we have a GPA variable. We're going to invoke the main method with short any name and the GPA as a string as a second argument because you can only invoke main with strings. And we expect that nothing is written to standard error, and what's written to standard out says has a GPA of the GPA. I think that's right. I'll run the test. We'll watch it fail. Okay. Aha. Okay, this is good. Expected a string that says that it contains has a GPA of 3.5. Instead, it's any name has a GPA of 0. Okay, well, why is that? Why do we have a GPA of 0? Because we always create a student with a GPA of 0, right? So what we did over here on the left is we sort of had some scaffolding code. It's perfectly okay, right? The nice thing about code, you can change it. It's like the most malleable substance known to humans, right? It's super easy to change. And so then it's okay if things are a little messy as long as you have tests that tell you what you need to clean up. Okay, so the same way that we got the arguments, the same way that we got the name from arg0, let's get the let's get the GPA from arg1. So instead of 0, what I'm going to do here is I'm going to refactor. I'm going to say introduce variable, and I'm just going to call it GPA. And instead of 0.0, what do I want to put here? Sorry? Well, okay, yeah, I like that. You could do it that way, and that'll make a test pass. But then if I had another test that had 3.4, what would I have to do, right? So then if I change this to 3.4 and ran it again, it's 3.4. Thank you. It's going to fail. So that's probably not what we want to do, right? Instead, what we want to do is take the value from the args array, right? So it's passed in on the command line as args1. And it's not happy. Why isn't it happy? Oh yeah, requires a double but provided a string. So our arguments are all strings, as they should be, coming from the command line. And we need to treat this as a double. Okay, how do we, does anyone remember or anybody know how to convert a string to a double in Java? Yeah, Ed? Yeah. Oh yeah, does it tell you? Oh yeah, wrap using dildo parsable. Okay, nothing wrong with that. Yay. Yeah, smart. Good, good, good. Okay, let's run it. Nice. Okay. So what do we see there? Okay, it's building out the main method a little bit more, but just like a line or two at a time, as long as you've got a unit test. Because the unit test tells you not whether or not it worked. Okay, one more thing that I want to demonstrate, and that is invalid. Let's see here. Let's see here. Invalid GPA issues error to standard error. Okay. Let's see here, not a GPA, invoke it with that. And then let's see here for input string. I don't like that. Instead, I'm going to say invalid GPA. So I want a string that says invalid GPA, the number, yeah, in double quotes, great, written to standard error. Okay, well let's run it and see what we get. Oh, we get all these main methods should not throw exceptions. So let's see what happens. Okay, so we got something called a number format exception from the parse double method when parse double was called on line 60. Okay, fair enough. What do we need to do to make this pass, to make this test pass? Yeah,
Put it in.
catch the exception. Exactly. So, here's what I'm going to do. I'm going to have I'm going to split this. Actually, it's something I can do in IntelliJ. And split declaration assignment. Now I've got the thing that invokes parse double on its own line, and then I can wrap it in a try catch block. Catch number format exception. Thank you, IntelliJ. And I don't want to rethrow it. Instead, I want to say system.error.println. Oh, it was sort of maybe it was error.println. Yeah, invalid GPA args1. Yeah, fair enough. And then return. Yeah, so that way we won't have that same problem again. Okay, let's run it, see if it still works. Okay, nice. So, again, I wrote a little test, testing both a happy path and an unhappy path, right? So the happy path is like, great, I've got a valid GPA. And it's like, oh, what happens when there's an invalid GPA? Oh, well, what I want to do is issue this error. We tried it out to see what it does out of the box. Oh, it threw an exception. You don't want to throw an exception. Instead, we handle the exception by catching it. And when the exception is thrown, when parse double does fail with a number format exception, then we don't freak out. We just issue an error message and return from our main method. Okay. Um, Handle the GPA. Anything else I can tell you about these tests that we put just now? Both the integration tests and the unit tests. You'll be writing a lot of your own unit tests and a lot of your own integration tests as part of the projects. You'll and so much so, well, and the way you'll know that you've written enough unit tests is that there's a code coverage analysis that you can run on your projects and I'll run on your projects. And the goal is to have at least 75% of your lines of code covered by your automated tests. And details about all that is in the screencast that I recorded on Tuesday. It's also there in the handouts. Yeah. Excellent. This is everything I wanted to show about test-driven development tonight. Let's take, is it okay to have 7 minutes? So at 6:35, let's reconvene and do some pair programming. Okay. So then, in the first part of class, we saw test-driven development, and the idea here is that you write your test first. You figure out what you want your code to do. You write some tests. You write a test that will validate that your code behaves the way that you want. And you do this in a unit test by invoking the Java methods that do the work. So you create some objects and you invoke some methods on them, and then you verify that they use the assert the assert APIs, the Hamcrest APIs, say, yep, this is what I expect to be true. And if it's not true, then Hamcrest will fail. We did that for the student class itself. And then when it comes to the main method, we have a slightly different approach to testing. There's still JUnit tests, but we rely on this invoke main method and the main method result object to then invoke the main method and capture what's written to standard output and standard. And you'll be using these same APIs and these same automated testing techniques in your projects. In the second part of class, I want to talk about pair programming. So next Wednesday, a week from tonight, we'll all be doing pair programming. And I wanted to tell you a bit about it and let you see some of it before you have to do it yourself. So I have posted a link to this in the class Slack. Encourage you to follow along. You won't have to write anything in it tonight, although you will next week. So we'll For the rest of the class tonight, we will be doing an activity where brave student volunteers pair with me on something called a code kata. A kata is a little exercise that you go through to learn a particular programming technique. Maybe it's like a new language, a new API, focus on something like refactoring or test-driven development. And it's not so much about like solving a problem as it is exploring the language of the technique, whatever. And we'll be doing a number of katas here in this course. And we will be writing that code all in the same GitHub repository. And we do this for a couple of reasons. Originally, I had students like create their own repositories when they paired up and when they mobbed, and it just took a ton of class time. So forget it. So I'll use one. Also, as an unintended consequence, everybody gets a good experience of what it's like to be working in a repository with lots of collaborators, right? So yeah, we've had some train wrecks over the years. We're like, oh gosh, all sorts of conflicting. I've tried to disambiguate all that. So very rarely are there code conflicts, but you'll probably find something like, oh, I just made some changes. I've committed them. I want to push them. Oh, wait, there are other changes I need to merge in first, right? Yeah, right. This is good real world experience. This is, the feedback that I've gotten is like, oh, this is how you really use Git. It's like, yeah, that's kind of what it's like working with other people. So what I'd like you all to do is go to this Kata's Winter 2026 repository in GitHub. This is off in the Joy of Coding organization. And this is a repository that I created. It's another copy of the Getting Started repository, just like the ones that you write your code in. But this is one that we all have access to. As a matter of fact, for those of you who provided me your GitHub ID when you filled out the survey program, I used that to then add you as a collaborator to this repository. So the first thing I'd like you to do, and feel free to do this here in real time so we can work through the problems, is to make yourself a clone of this repository. It's a public repository. Everybody should be able to clone it. And then in your favorite editor, or if you just want to do it here in GitHub, I suppose you can, open up this file called I can edit this repo.txt. And in this file, please find your initials. I believe I have everybody's initials here, and replace it with the word here in your local file. And then as a test, to see if you can push it to the database, please commit that change to Git and then push it up to GitHub. As you can see, some people already have. And this will be the test to make sure that you can access the GitHub repository. So let's give folks a moment or two to get that started. I realize some people already have. See people hard at work there. It's good. Meanwhile, I'll say a few words about pair programming. I've got a lecture on it. Please watch it. It does provide a lot of background on, yes, the why of pair programming, but also the how. While pair programming is sort of simple in concept, like two people working together, especially when you get started, it really helps to follow a structure, to be more deliberate about what you're doing so that you can get the signals about what works and what doesn't, and so you can quickly adapt. It's not just two people talking to each other. It's really more of, and it's certainly not one person talking. There's more involved there. So actually, on that, I'm going to play another cheesy video. Let me share my screen a different way. That talks about pair programming. Let's see here. Share sound, optimize for video, entire desktop. Over here, motion pair programming. Okay.
Hello, and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds a record. Oh,
Alright.
probably in save data file. So it's going through, looks like a list of records.
So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
Why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling.
Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner.
Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation, for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
"17 years ago." Yeah, I know, right? December 5th, 2008. It was a good time. Yeah, okay, it's cheesy, but it's still true, right? Okay, awesome. I'll stop this nonsense. Cool. So what did you observe in all of that in the video? What are some of your key takeaways? And was there anything surprising? Anything noteworthy? Yeah. Talking, speaking up. Yes, yeah. Keep it. Keep the conversation going. Yeah. Don't dominate. Don't check out. It's sort of like, yeah, you're there to work with somebody else. Good. Yeah. Yeah. Right. Yeah. So don't realize that there are two minds involved, and maybe you might see certain things one way, but that can be that can just lead both of you in the wrong direction if you're not talking, if you're not coordinating, if you're not considering other ideas. Awesome. Good deal. Well, and so then, that was a video about apparently talk about the driver and the navigator. So there are these two roles. So the driver is the person who's actually hands-on keyboard, and really they're focused on so much, writing the code, the syntax, using the tools, not so much what code should be written. That's more with the navigator. So with the navigator is the person who starts saying, okay, yeah, hey, how about you write a test to do this? And, okay, yeah, you can use this keyword to do that. Oh, that's where you use an test annotation. That's what the navigator is doing. The driver is just inputting. It's really important in pairing to switch both, right? So you get practice at both, and so that no one person gets tired of typing or is tired of trying to explain things. You'll learn about these in the lecture if you haven't watched it, but there are different kinds of pairing. There's strong style, which is good when you have maybe someone there's more experience and one is less experience. It's not just like one person watching another person code. It really is having that conversation. It's a mentoring relationship. But then probably what you'll see more in this class is more like ping pong pairing, where it's like, hey, one person will be the driver, will be the navigator, and then they switch pretty often, and things just sort of ping pong back and forth. There are some more resources. I encourage you to check them out. What we'll be doing is using GitHub to collaborate. So, don't touch those keyboards. It's still, pandemic's still too soon. When at one point, like the department had gotten me like these big, huge, clicky USB keyboards. I don't know if they're still around. We try to use them. No one liked them. So just use your own machine, watch over people's shoulders, use you can use Zoom to collaborate if you want to share screens and stuff. But go that way. And so what we have these rounds of pair programming, and what we do at the end of the round is commit the code, push it up to GitHub, and then start the next round. The next driver pulls it down and goes from there. So what we'll be doing tonight is what's called the FizzBuzz kata. Has anybody heard of this? I guess most people have, right? Okay, so basically it's a very simple program. And the idea is based on a game the children play. I'm sure it's all made up. And so the teacher will say a number, and then the students will say that number back, unless the number is divisible by, where are the rules? If the number is divisible by 3, you say fizz. If the number is divisible by 5, you say buzz. If it's divisible by both 3 and 5, you say fizz buzz. I think you can figure out the algorithm. It's pretty straightforward. And what we're going to be doing is implementing this algorithm. Not because it's an interesting algorithm to implement, it's because it's how we're going to explore pair programming. So, and the way we're going to be doing this mechanically is all collaborating on the repository. So, I hope everybody, or as most people, have a checkout of the katas repository. In the katas repository, there is a project for FizzBuzz. I hope everybody sees that. And in that FizzBuzz, there is a pom.xml. I would appreciate it if we get some volunteers to pair with me tonight. And the way you sign up to be a volunteer is that you find one of these entries in the developer section right here in the pom.xml for FizzBuzz. Put your name in and say whether you'd like to be a driver or a navigator. So if you would, take a moment and do that. And actually, let me know when you've pushed up to GitHub, and you can come up and we'll pair together. Who wants to volunteer? No, actually, who's going to volunteer? I'll give you one. Yeah. Oh yeah, the old yeah, okay, fair enough. If you're the navigator, yeah, you can tell you don't have to use a computer. Yeah, if you want to be a navigator, okay, cool. Yeah, right on. Oh, look at that encouragement. I'm so relieved it's not me. Yeah, okay. It's hard to be the first guy. Okay, excellent. So sorry, remind me again your name. Aaron.
Yep.
Okay. Yeah, okay. You will be. I'll put you down at the bottom because I'm sure I'll put you down here. So, and let's see here. Thank you, Aaron. And you're going to be a navigator. Okay. So.
Catarina just had students in their full stack class.
Oh, really? Okay. Good. Okay. So, okay. Had you do FizzBuzz?
Yeah.
Okay.
Exactly
Nice. Okay.
Yeah.
Okay. So thanks, Aaron. Let's get started. So let's do test room development. So there is a unit test for FizzBuzz right here. It's got it's got a very much Canon Sensei Takata class. Right. Let's just make sure it works. And so let's see here. As navigator, how about you suggest the first unit test to write? Oh, sorry. We want to start a timer here. Let's just go for like 5 minutes. And then we'll retrospect once I get the timer going. 20 minutes, 5 minutes, 5 minutes. Okay, good. It passes. What do you recommend for our first test?
So I assume it's gonna iterate through like say 1 to 100 or something. So
yeah,
maybe we want to check that it's actually printing anything at all to standard or to just standard output, I guess.
Okay. Boy, it seems like a lot for a first test, though. It's like, what's something? Is there something simpler that you can think of?
Well, doesn't that test there already kind of successfully test that we can create the?
That is true. All we can do is instantiate a class, and actually, let's take a look at what this class actually is. Not too much. And that's fine. That's fine. So where's the FizzBuzz? So it's all out of the way. FizzBuzz test. Let's move this over to the bright, and then we'll make everything big. Nice. Okay, yeah. So basically, all it's doing is creating. Yeah, there's actually 0 argument structure. So I don't think this is even interesting. I'm just going to delete this one. Is it okay if I delete this one?
Yeah, sure.
Yeah. No, you're a navigator. You shouldn't be bossy. So, what's the first test that we should write?
Maybe is anything making it out to stand it out? Just anything at all?
Well, so if we want to do so what would that anything be?
Well, I mean, assume it's supposed to be an int, but it's probably them.
Yeah, like the number 1.
Yeah, sure.
Okay, so if we're going to be testing standard out, we should probably be doing this in the integration test instead, which is going to be fine. So let's start with the integration test. Actually, okay, I'm just going to refer all this stuff. Cool. Nothing wrong with that. And so then, we're just getting started. FizzBuzz integration test. Great. Okay. So then, what do you want to send to the main method? So, like, if we invoke the main method, what's the input, and so what's the output?
Okay, let's say maybe command line argument that gives you the upper number. So there's 110.
Great. Okay. So invoking. Let's see here. So then, 10 prints first 10 FizzBuzz. I don't know. Does that make sense? Okay. And so then, if we that's kind of nice.
Wow.
What do we think? Is that the right thing? Okay. Okay, good. That's 10, 9 and 10. 10? Yeah, there's only 5. Yeah, okay. Okay, cool. Okay, so now what do we need to implement?
The whole program.
Yeah, boy, that seems to be pretty big as a first step. Is there a smaller first step that we could take? Which maybe isn't related to the command line? I don't know.
Isn't related to the command line.
Well, I mean, do we have if the FizzBuzz class itself, what would this, what do we what if we had a method here that just did one number?
Yeah, sure.
Okay. And that seems to me more like a unit test. So what's a good, so if we're just going to say the logic for just one one number, what would that be?
Logic for one. So we already kind of decided that command line would take in the upper ceiling. So maybe if they feed in 1, it just spits out 1.
Okay. Yeah, I like that. Yeah, FizzBuzz of 1 is 1. Nice. Is creating a FizzBuzz object? I don't think I like that very much. Let's just use a static method instead. So if we just have FizzBuzz dot, let's call it FizzBuzz of 1, and then this will be a string, right? Because it's gonna be the string 1. And then, okay, so we've got this method. I'm just going to create it right now so it compiles. All right, number. And then what do we want over here in the test? Oh, no, we don't want that. We want something. See, we want that assert that.
Contains one.
Okay, I like that. Yeah. One. Actually, I would say equal to. Right? Because I mean, I think all it does is. Wouldn't what always be true? Well, this is when you give it the number. Oh, that's a great question. So then, normally I wouldn't take questions from the audience, but it's like here, don't sit down yet. Here, the FizzBuzz method, it takes an int and returns a string. Because like eventually for 5, we want to return like fizz or something like that. So I think this is the right test. Yeah. Let's run it. Let's give it a chance.
Is equal to convert or the string one equal to what looks like no, that is a string one. Okay.
Yep, this is the string one because it's in double quotes. Yep. Nice. And look, it failed with a expected 1 but was null. Okay. Not surprising there. But your time is up. And so don't go yet. We have after you do a round of pairing, it's always good to do a little retrospective, a little reflection on what it is. And I guess I knew this term. I make cards like prompting questions. So let's see here. Okay, how did we ensure that everyone felt included and valued? Did you feel included and valued?
Felt there included and valued.
And valued. Thank you. Good. How do we do that?
It's kind of having like a relaxed atmosphere up here.
Okay.
A lot of kind of trying to work through it together. I don't know.
Yeah, I think we had a good, and I'm glad that like we're familiar enough with like the problem and everything like that, so we could talk about it. Pretty awesome. Thanks, Aaron. Appreciate it. Hey, that's all I have a hand for Aaron. Okay. Excellent. Who's next? Yeah, Alex. Yeah, okay. Awesome. Let's see here. Alex, did you make a change to the pom.xml? If not this, no, you don't have to. Well, and
my laptop time.
Okay. Oh, you know what? I need to bring his extension cord, right? Because everybody.
I
Yeah.
forgot.
Nothing wrong with that. Yeah. So make sure to bring your power cable on next Wednesday. Okay. So thanks, Alex. So then, so previously on pair programming, we have a failing test. How do we make it pass?
Yeah. Well, that return null is relatively null, obviously. So we want to, instead of null, we want to make it return one.
Okay.
Yeah.
So return 1 like this.
Yeah.
Okay. Nice. Okay. I got a approach. Now I need to build it first. Yeah, it passed. Awesome. Cool. Okay. Got any ideas for the next test that we should write?
Yeah. I suppose we need to do where we pass it 1 and 2, and then just see the output being 1 and 2.
Pass this method 1 and 2.
We got 2. We just need 2. Yeah.
Okay.
2 and 1 and 2. Yeah.
Gotcha. So okay. So how about this? I'll just duplicate this right here and say FizzBuzz of 2 is 2. Right, because FizzBuzz of 2 is 2. Okay, so then if we pass in 2 here, then we get 2 there. Yeah?
Yeah.
Okay. Run that.
1 and 2.
Oh, sorry, like the variable name?
Yeah.
Like that?
Yeah.
Good.
Yeah. Yeah.
Okay.
Yeah. Anyway.
Okay, so now it's failing, so then yeah, we should make a pass.
We obviously we want to make sure. Well, it's going to return 1 every time.
Yeah.
So we want to have no if statement.
Oh, okay.
If number is 1, then we want to return 1. Number is 2, then we return 2.
Okay. Yeah, I'm game for that. So number is 1, then return 1. Otherwise, return 2.
Yeah, I guess that would be 6 1.
Okay, we can do it that way.
Yeah, I was thinking
Oh yeah.
No, I understand what you said. Yeah.
I'm gonna go for the most annoying syntax ever, so that we can maybe do it.
No, I do this all the time.
Okay, nice. Okay, what's next? I like this red green.
No. Okay, now we want to. Now we want to see if it's 3. If 3
Okay.
needs to be fizz.
Yeah. FizzBuzz of 3 is fizz. Okay.
Yeah, okay.
Let's watch it fail. Okay. What do you want to do now?
Well, now to well, we need probably.
You want that if statement now?
Yeah, we probably need a statement now.
Let's see here. Flip, replace with a statement. There we go. Nice.
And then we'd have the else with two.
Okay.
Or, yeah. Oh, yeah. I guess. Yeah. Else. Yeah.
Oh, else. Yeah.
Two and two. Else.
Ooh, okay. I like this. This is it's kind of hard. Oops, I don't want to run the main method. I want to run. Sorry. I want to run this. Yeah, that worked. Okay. What now? Oh, sorry. Is there an opportunity to refactor? We do less red green. Is there an opportunity to refactor? Yeah.
I was just thinking about that. Yeah.
I run them all just to make sure. I'm looking at these tests and they look a lot alike. I wonder if we can refactor because yeah, it's parameterized this. Yeah, so what if we did something like this? We just said we'll make a variable, so refactor, introduce variable. Let's call it number, and then we'll have this be, I don't know, is buzz value or something. Refactor, introduce variable, is buzz result. And then I'm going to move that up a line. No, I'm going to move that up a line. And then I think we can just say, I think we can put all this into a method. Refactor, extract method, and we'll call it, was it able to do that? No, it was not. We're gonna read all of this. Let's say refactor, extract method. Here we go. And we'll call it what? Assert FizzBuzz. And it finds other places that I can use it. Let's replace them all. Nice, look at that. Cool. Yeah, cool. Okay, and then just in time too. So we're gonna run this again, and we're gonna do a quick little reflection. Ooh, what challenges did we face, and how can we overcome them in the future? What's the challenges that we faced?
Well, I suppose for myself, I didn't realize I just challenge was that I wasn't great at thinking about refactoring. That's the challenge. But I was challenge. Oh, names. I was not helping with names at all.
Oh, the names of what?
Names of
function variables.
Variables. Yeah, that's on my.
That was pretty good. Excellent. Cool. What observations from these two? Thank you very much, Alex. Let's give a quick clap. Observations about what we just saw in those two pairing sessions. Super simple. I mean, say more. What do you mean by super simple? Gotcha. Yeah, and we're developing a suite of tests so that as we probably make this be a little bit more interesting over here in the implementation of it, we'll know that the other one's fast. Great. Other observations? Yeah. Yeah. Yeah, right. The design wasn't clear from the requirement, which is often the case. And so it's something that the pairs, they need to figure out, which is, hey, how exactly we're going to approach this. When we do our pairing exercise next time, we will start out with a couple of minutes just to have the pair brainstorm. what the solution is, or take some notes, do a little bit of whiteboarding and things like that. So not writing the code, but just sort of doing some game planning. We didn't take the time to do that. So, any other observations? Excellent. Then I will commit this a little bit later because now class is over. So just want to give a quick preview of next week. Again, there is no class. The university's closed. It's a holiday. It's Martin Luther King Jr. Day. Please take some time to reflect on why we're celebrating, what we're celebrating, the amazing progress that we've made, and the work that's left to be done. And then we will all see each other again next Wednesday for our first pair programming experience. You'll all be doing this as pairs. Bring an HDMI cable so you can take advantage of the projectors if you want. If you ever want to use the projectors in this classroom, this is the time to do it. Yeah, I'll have cables. You don't need cables. And there'll be lots of cards to play with also. So looking forward to it. We'll see you then. Stay warm, stay safe, and we'll talk on Slack. Bye, everyone.
Thank you.
Bye now.